Welcome to the Orchestrate All the Things podcast. I'm George Anatiotis and we'll be connecting the dots together. Knowledge graphs are probably the best technology we have for data integration. But what about application integration? Knowledge graphs can help there too, argues EnterpriseWeb. I hope you will enjoy the podcast. If you like my work, you can follow Link Data Orchestration on Twitter, LinkedIn, and Facebook.
I'm Duggal. I'm the founder and CEO of EnterpriseWeb. I've essentially spent my entire career building, turning around, growing, starting companies. And this is my latest instantiation of myself. I'm a regular speaker at tech conferences, including some of yours, an occasional blogger, and the inventor of 15 awarded patents on complex distributed systems.
Okay.
If you, so that's me. I don't know if you want me to go a little bit more broadly. Company, I think you also said.
Yeah. It's a good introduction of you basically, and I was wondering, yes, the next part would be if you would like to describe Enterprise Web in a nutshell and what you do.
In a nutshell, EnterpriseWeb is a no-code platform, right? So it is, in the past, you might have called that a model-driven platform, right? And one of the distinguishing features of EnterpriseWeb's no-code platform, and I think what makes it relevant to today's conversation, is that the core of EnterpriseWeb is we're using graph modeling and graph processing. Mm-hmm. So that's the key. So now I think this is very distinct from traditional uses of graphs for analytics and recommendations, as we might see in a semantic web. Different, not versus, right? Maybe actually complementary in many ways, actually. But EnterpriseWeb is a no-code platform for rapidly composing complex distributed domains so that you could model your operations across your increasingly distributed and diverse endpoints that represent your operations, and that you can connect them in end-to-end event-driven processes. It's a real big problem for organizations around the world as they've sort of disaggregated from being monoliths to services to microservices and now serverless functions. They've had an explosion of endpoints, which now they have to connect and manage, and this has been a struggle. So as much as being modular and distributed and cloud native, those are all good things. An enterprise still has to act as an enterprise. It still it has to have unified visibility, discovery. It wants to have automation of its processes. It wants to have consistency in policy. It wants to have management. So EnterpriseWeb is a no-code platform made very much for this moment in time. People are struggling with complex distributed systems. EnterpriseWeb uses graphs to model those systems, to model the complex graph dependencies, and then to use graph processing to efficiently process all of those dependencies so that people get real-time intelligent services. Does that make sense?
Yeah. And even though I was at least somewhat familiar with what you do, I have to say that the graph aspect that you chose to focus on, at least in this conversation and in the previous couple of conversations we've had as well, somehow did not occur to me. It makes lots of sense, actually, that if you are trying to solve the kind of problems that you are, then you would eventually stumble upon graph, let's say. But well, at least, maybe it's me, but I didn't think it was that much pronounced, let's say, in your messaging, or it was such a central piece of how you approach things. Under the hood, well, I'm sure you're going to have the chance to explain in more detail the ways in which you use that. But I think it's maybe a good idea if we take a step back before we actually go into all the nitty-gritty details of graphs and how you use them, and to try to explain a little bit the actual domain that you're in. And well, I'd like to share how I first got to be acquainted with that. And in some ways, I think it's kind of like an age-old problem in IT. So when you have in the beginning it was in-house services and off-the-shelf solutions, and people were trying to build their own services. Everything was running on their own data centers, and obviously you had to somehow, well, dealing with a specific isolated, let's say, functionality is all fine and well, but the real value comes when you are able to integrate those islands, let's say, of functionality across the enterprise to get, well, bigger things done. And so this has always been something that people were pursuing with a number of different ways and a number of different platforms that have come and gone out of in and out of fashion over the years. So business process modeling and data and application integration and so on and so forth. So as you hinted in your introduction, over the years, if anything, this has gotten to be even more complex and complicated because there's a proliferation of services and endpoints, and we've moved from mostly 100% on-premise to, well, if not 100%, but in some cases close to that in the cloud. And we've gone from monoliths, so single and uniformly architected services to microservices, and from that to, as you also mentioned, serverless functions. So it's going more and more granular, which is good in a way, but it also means that it's getting more and more complicated. So since you have been in that space for quite a while, I was wondering, what are your takeaways from everything you've seen and throughout the years?
Yeah, so I think one of the points you made at the outset was interesting, is how we would stumble on graph. And I think in a way, I don't know if I'd use the word stumble, but I think that the reason we came to graph was part of a very intentional design, right? Because is that the way that the traditional development that you're talking about happens, right? Even to this day, is manual code and manual integration primarily, right? You code and recode, integrate and reintegrate. And of course, that does not scale for today's demands, right? So graph, we looked at graph structures, non-hierarchical structures, dynamic structures, right? We were looking for real-time event-driven applications. We wanted to be dynamic typing, right? Prototypal inheritance, not hierarchical class-based inheritance. So we were looking at a lot of properties we wanted to achieve, and those properties drove the design decisions, and that led us to graph very quickly. And actually, part of that was also our reading of the computer science and the system engineering literature. So to your point, at one point, everything was on a mainframe, right? Everything was, actually before that, it was just Turing, right? It was this never-ending tape, right? We had the zeros and ones on a tape. But then it became a mainframe, right? The mainframe was on premise, and it was the big centralized monolith. Everything was in there. And now what's interesting about the mainframe, one of the reasons they're still around, is they're very powerful. One of the reasons that mainframes are very powerful is that on the mainframe, data and code live together, right? There's not this false divide of the data team and the application team, right? It didn't exist yet, right? It was all together. Data and code were just zeros and ones with addresses, right? A mainframe has something called unifying principles, right? It essentially has an isomorphism. It has a common methods, common way of representing things, and common methods for handling those things that make the mainframe really powerful. Then comes distributed computing, and of course, that's great. I mean, so mainframe had its heyday, right, when things were highly centralized, slow to change, right? That was fine. Command and control, mainframe, great. So now we're distributed. We have a whole host of new capabilities, but we also have a whole new host of challenges. The reason we have a whole new host of challenges is that when we disaggregated from the mainframe and then monolithic applications, which were just tightly coupled balls of mud, right, to then more service-based applications, to then microservices and now service functions, is we disaggregated without having a programming model for composition and management. In other words, we took everything apart, Humpty Dumpty broke, right? All the pieces were on the floor, but we failed to actually introduce a mechanism, a means, a method for composing those things back together. And so look at where we are today, right? It's exactly the problem we have, right? So okay, 10 years ago, we had big bloated middleware stacks. Those are starting to go away now. What are they being replaced by? Cloud native tools. What are cloud native tools? They're just disaggregated capabilities that came out of the middleware stacks, right? So you used to have 12 bloated middleware components that did everything. And that was complicated as it was, and it was pretty opaque, and it was tightly coupled together, and things became pretty static. Now, go look at the Cloud Native Computing Foundation's vendor landscape, and you'll see hundreds of cloud native tools. And what do those tools represent? Very small, granular, discrete capabilities like Kafka events, and you have various things doing very specific functionality. The problem with that now is who ties that all back together, right? Kafka is not your entire information system. Kafka is not an application development platform. Kafka is not really a data management platform. So how do I get an information system out of Kafka and a dozen other tools? They make it sound so easy when you read the industry articles, right? You look at, it's the same old pitch from the middleware days. Every middleware component looks fine in isolation. Hey, look at this new component. You need it for analytics. Look at this new component. You need it for events. Look at this one thing, this component. But what people forget is it's the N+1 problem. Every time you add another component, you're adding overhead and complexity to your system architecture. You're not recognizing it. It's accidental complexity. And it's the same darn problem with your cloud native tool chains, which have now become unwieldy. And now in the cloud, you have to, when you put those things together, who is actually caring about the consistency problem? Whose responsibility is immutability? Whose responsibility is idempotency? Whose responsibility is asynchrony and concurrency? Or let's talk about non-functioning concerns like security, compliance. Whose responsibility for it? Oh my God, the systems engineer has to put that all together now, right? Enterprise web is a reaction to that kind of modular reductionism, right? When I founded this company, I had experiences to building things those ways and seeing how static that left my operations that are the companies I was running. That the things that were supposed to be driving my automation were becoming concrete and were stopping me from being agile. So I was like, okay, I want to solve this problem fundamentally. I've been around the block a couple of times. I want to address this. I read hundreds of academic papers, hundreds of engineering papers and tech articles and things like that. I just processed this entire universe and came up with a thesis as to, okay, you know what, there's really a right way to do this for use graphs to create a no-code environment, so hide all the technical complexity, use graphs to model declarative relationships between all your solution elements, and then to use graphs to enable declarative composition of objects into services, and then use graphs for chaining services into event-driven processes. So EnterpriseWeb essentially reintroduces unifying properties. You have one way of representing everything, whether it's a Cisco router, function, a cloud native tool, database, everything is represented as a graph object. It's an abstract data type in EnterpriseWeb. All those objects are modeled up to an ontology, or graph knowledge base, which has higher level enterprise and systems concepts, right? And so everything is mapped up to this higher level. We can call that an upper ontology, really, right? And that is defines the higher level domain. And then you have the objects of your domain. The objects of your domain are now completely defined in metadata and relationships and state. And now I could use those things to drive my processes. My model is describing all of my objects. It presents an abstraction, a common language for describing all my heterogeneous and distributed solution elements, right, which are actually all snowflakes, but it's not useful for me to work with them with snowflakes. I'd like to have one common abstraction layer, one common consistency layer, where everything looks the same to me. You could never do this in a hierarchical approach, right? because it would be too static, too rigid, right? It wouldn't support the real world diversity, the real world complexity, the real world one-to-many relationships, the real world change, right? Graphs are inherently flexible, extensible, and adaptable, right? They have these attributes that make them valuable for doing what we do. So it's core to our IP, those 15 patents, right? Is our use of graphs to solve these distributed systems problems. I mean, so just one last segue on that is traditionally, of course, the use of graphs has been for analytics and recommendations. Not for processing transactions and business processes, right? The reason for that is because the complexity of these individual objects, right? We're not just talking about semantic web with huge collections of facts, right? What we're talking about is a domain that could become very equally complex and complex, but very then rich objects that are individually rich, right? That have lots of properties, behaviors, dependencies, constraints, affinities. All of those things are modeled in our graphs in Enterprise Web, right? They're all aggregated and addressable. They're made so that they're hyper efficient for processing. So Enterprise Web is making graphs practical, practical implementation of graph technology for application modeling and development. Actually really design, deployment, and management, right? So it's a full platform. So as opposed to semantic web or label property graphs, which are really more query engines, right? Or they're models that are then accessed by queries. Enterprise Web is doing queries and commands, right? We're actually taking actions against these graphs.
Yeah, actually, I was going to highlight precisely this aspect. So a lot of what you described should be familiar to people doing, well, what's today called enterprise knowledge graphs, what at some point used to be called data integration, or I don't know, for some other people in context they may be doing that for what they call master data management or what have you. But basically the underlying idea is the same. So fine, I have all these data islands, these data sources lying around in the enterprise. Each one of those has its own data model, which may be, arbitrarily complex. And I want to actually have a unified view over all of those without having, to move them in a data warehouse and do all those nasty ETLs, which cost, lots of processing time and lots of effort. So federation and sort of common data model that enables me to look at the entire landscape, hopefully and hopefully that way have a better picture. The difference is that in your case, you don't just do that, but you actually do that as a means to an end, which is that you want to functionally integrate those systems to which those data models belong. So I was wondering if you could tell us just how do you, well, first of all, how do you introspect all those systems to get the data models, and how you mentioned in your previous answer, you mentioned a sort of top level ontology. So was that a kind of metaphor, or do you actually use something equivalent to an ontology? And how do you populate this ontology of yours? And then how do you do the data alignment? Because that's another part which is common with people doing enterprise knowledge graph work. They have to, in addition to creating a data model for each of their data sources, they need to somehow align that. So how do you approach those challenges?
All right, so that's a lot. So you just said, so I have to unpack all of that. So, but I completely agree. I mean, so I would like to think that these things should be familiar. I think the most recent movement now is the data fabric, right?
Mm-hmm.
The data mesh. I'm sorry, is what people are saying now, right? And it's for this very same motivations, right? And it's actually still, it's a to be thing. There's nobody really offering, data meshes really today. It's an idea that people would like because people would like global visibility, right? People would like to have a common place to query. People would like to be able to introspect their diverse and distributed data sources. Of course, we're extending that to the application side as well, right? We look at data and application being the same, data and functionality being the same side, two sides of the same coin, right? You know, just as it was in the mainframe, data and code ran together. It's not data against code or code against data. I think unfortunately we have some folks who idealize or reify data over everything or code over everything, and that's both are silly actually, really, because applications generate data and data is consumed by applications. This is one thing really, right? So in our world, we call this approach not a data mesh, we call it an application fabric. That data sources are just one aspect, but we're also connecting systems, not just databases and data sources, but traditional data sources, but also equipment, devices, calling out functions. So, so that we call that the application fabric. And I think then you segue from that basis or the foundational motivation there for visibility. And then I think you were asking about how do we bring people in. Actually, I'll do it in reverse order. You asked how do we bring these elements in? How do we discover them? And then how does that connect to a model?
Mm-hmm.
I'll answer it in reverse order. So the model. So EnterpriseWeb comes out of the box with a model that's ready to use. Remember, we're a no-code platform, so the whole point of EnterpriseWeb is making it easy, right? Improve IT productivity, accelerate service velocity, provide business agility, right? We're using, traditionally no code has been used for simple applications, right? Business users, citizen developers, relatively simple applications. EnterpriseWeb supports real-time, event-driven distributed applications, web scale processes. Actually, sort of the holy grail right now in the cloud is something called stateful cloud native applications, the ability to use state with cloud native applications. That's a really big deal. We do that. So EnterpriseWeb is a no-code platform that tackles the hard problems that enterprise struggles with. Because if you have a no-code solution that's sort of just for simple things, as soon as your application becomes mildly complex, guess who you're calling again? IT, right? And now you're coding and re-coding and integrating and reintegrating again. And you're now sort of half pregnant, right? So the idea of EnterpriseWeb was to create a unified model, a unified programming model, unified approach to help people connect their distributed and diverse endpoints and run automation across those. To your point though about, let's start with the model. So EnterpriseWeb comes out of the box with a baseline model because guess what? We've been around. We know what an enterprise looks like. We know an enterprise made out of units, locations, facilities, people, right? It has all of these kind of concepts, right? And we can model those concepts in the abstract, right? As universal concepts, right? And then same thing with system concepts, right? EnterpriseWeb understands the cloud, right? We understand distributed systems. We understand types, formats, schemas, right? We understand all those concepts. Now, those concepts apply to many, many, many implementations, and might apply very differently in many, many different contexts. That's fine. That's the whole role of upper ontology, right? Is to actually provide that sort of higher level commonplace, right? That's useful, and then by having that model, it makes it easy for us then to go to customers, and they can either go to start working in scratch, use our baseline as their starting place, and they could just model manually if they want. And they could just start with a use case. They can start that way. So this complete and this would be the role of, let's say, a software architect, right? So a solution architect, systems architect would come in, and they would model the domain, whatever the scope of the domain is, right? So we work with customers like in telecom doing, 5G edge, which is just probably the biggest distributed systems domain that there really is out there right now that needs to be automated. And EnterpriseWeb is on the cutting edge of that. It could be the domain of a line of business. Doesn't really matter, but you could start there. You could manually go in there, and we give you a design environment that is both accessible by API or user interface. And so you have a design environment that allows you to, rapidly model your domain inside EnterpriseWeb using the baseline as a jumpstart. But then we also give you tools like, well, we can import RDF, we can import XML, We can import, pseudo UML, even like documents. You could give us a PDF document that has pseudo UML in it, and we could do entity extraction, entity recognition, algorithmic, extraction, right, and map those to the concepts in our system. And we've done this for companies that are in the domain of $100 billion plus, right? Where they're like, oh, hey, we have a JSON file. Could you import that and then essentially map our model, which might be done in a less dynamic way, in a more hierarchical model, a less useful way? Can we import in that model into EnterpriseWeb and make it actionable? And the answer is, yeah, we do that like in seconds. With any such import, you'd want to have somebody who knows that domain to manually review it, right? Because that's just responsible. Now, our algorithmic mapping tends to be 95, 98, 99% accurate. Of course, in a big domain, that 3-4% could be quite a little massaging here and there. But it's still a huge bootstrap, right? And so that gives you a customer an ability to implement a domain within EnterpriseWeb very quickly to create. So essentially, EnterpriseWeb is almost like a DSL for DSLs, right? They're creating a domain-specific language inside EnterpriseWeb, which provides the foundational metadata relationships and policies for them to sort of navigate that domain and use that to model their domain objects. So once that's in there, and that can happen in a day, 2 days, depending on the complexity of the domain. We've already modeled some domains quite richly. So in the life sciences or in telecom, just this project with SAP, So we've actually modeled some domains that are also like industry kits. You can almost imagine starter kits, where we have our baseline upper ontology, plus then we have sort of the domain, and now we even have catalogs in those domains. We have catalogs of widely adopted objects that are already used in there in those domains. So we can jumpstart things quite effectively. Then what happens is when you want to when you start onboarding your own solution elements, right? Your own domain elements, whether they're applications and artifacts, systems and services, service endpoints, databases and devices, et cetera. What you do is EnterpriseWeb exposes effectively like a wizard. That wizard, or you can call that a dynamic UI or an interactive API, but effectively you're interacting with our type system. You say, I want to onboard this, or I want to model this endpoint. I want to onboard X, right? And the system goes, it wants you to type it, right? So then you say, okay, well, what is X? X is this. Okay, well, we know a lot about these kind of things. And then it asks you like the next 10 questions, right? And then you feed those 10 questions, and it goes, okay, well, we know a lot more about these things now, right? And then what the system is doing is auto-filling your properties and auto-generating your interfaces as you go. I mean, to give you an example, and again, this might not be an example that many people are hands-on familiar with, but I think they could guess at the complexity. In telecom, something like a Cisco router, or Juniper router, or Sienna router, those are very advanced technologies. In fact, what they do at such high speeds, but they're actually fairly straightforward. We can onboard something like that in like 30 minutes. In fact, we have all 3 of those already in our catalog, so they're available as models already. But if you want to take something more complex, that might be more disaggregated, might be more cloud native in its design. Well, that might take an hour to onboard in EnterpriseWeb. In telecom, traditionally, those kind of elements take 4 to 6 weeks and 4 to 5 teams to onboard. So we're taking elements that in telecom are known to take weeks with multiple teams to onboard something. We reduce that effort to 30, 60 minutes, right? We even do more complex things, the 5G core and all these other things that are really fundamental to today's modern communication structures. And we can onboard those in a couple of hours, but these are vastly complex technologies. So these are radical simplifications for that onboarding. And here's the bottom line for that. So you put that effort in, right? So you have some architectural effort, right? You do some modeling of the domains. You've got some onboarding effort. That's like your IT team. does some onboarding, and essentially they're populating a catalog. And we actually support things like BizDev, um, uh, DevSecOps, right? So that you can actually go through a process of testing things as you onboard them, automated testing and human oversight and approval, all those kind of things like that. So you can put it through. Then it completes those processes, get registered in a catalog. Now all those things in the catalog are completely described in metadata, right? I can discover them the same way, right? I use that metadata to discover them. If I'm a service designer now, I literally go to the catalog, I search it, point and click the things I want. I could search by type, I could search by name, I could search by property, right? I find the items I want, I compose them onto a design palette. I don't have to know anything about the technology about those objects. I don't have to understand their properties, their formats, I don't have to understand the protocols. I don't have to worry about manual integration. The system will bind them for me because the system understands each object independently. Each object is a well understood, isolated, immutable object in Enterprise Web. It understands each one of them in isolation, and when you compose them, it understands the distinctions between the schemas, the formats, the types. It will mediate the relationships between those elements, right? And it's all doing that based on the graph knowledge base, on its higher level knowledge of the domain, which it translates then to low level implementations. And so the runtime literally then, so the service designer composes that. All they really have to do is pick the elements they want, write the essentially service logic they want, maybe the SLAs that they want, but that's all business logic, right? That's all policy. It's all fully declarative. They don't even have to worry about where it's going to run. They could say, they can essentially, the service could run on any infrastructure, right? It could run on Amazon. We could deploy the service to the Amazon cloud, to the Google cloud, to an enterprise cloud. The system doesn't care. The system will, that endpoint where it's going to run, that environment, that target host, will also be a modeled object in Enterprise Web. It's another type of object that, and when you try to deploy that service, the service will look for either the specified target host environment to run, or it will translate the policies to identify an available and applicable target host and deploy the system onto that. But the translation and transformation to do that, because remember, running services on Amazon is similar to running it in Google or Azure, but it's not the same. They all have different service endpoints, right? Same thing an internal target host will have different service endpoints as well for their infrastructure services. But Enterprise Web is making those services protocol agnostic and infrastructure independent. So we've really reduced the application effort to a design function of composition, and then the system is handling all of the implementation detail. It's providing a real-time trace of every single thing the system did to perform those tasks. If something fails along the way, Enterprise Web is transactional in the sense that it has compensations, retries, compensations, and rollbacks, so that is all done. And that's all done by graph. And what we've done here is, now it's interesting, in the application world, people are starting to talk about graph, but they tend to model in graph and then implement traditionally, right? Like things like network topologies are understood to be graphs, but they don't have ways to deploy them as graphs, right? Enterprise Web, by keeping things unified, by doing graph modeling and graph processing, once again, we're stripping out overhead, we're stripping out cruft, we're stripping out latency, right? We're stripping out, Enterprise Web was designed to be optimally efficient because we want to use as much data as possible, right, to drive the most optimized decisions in real time. And we're hiding this complexity so that you don't have to worry about those details, but we can expose that there's to the person with the right permissions, you can see those details. So now I'm sorry, I answered in length. You actually had like 3 or 4 questions in there, and I wanted to sort of give each one its due. So sorry for the monologue.
Well, one thing I wanted to ask you, just by I assure you that I listened carefully to all of it. So, and to prove it to you, one thing I wanted to ask was that you used the router example in your answer. So, and that's, for most of us, that's a little bit exotic. So most of us don't really have to deal with this type of hardware. They don't have to configure it. They don't know its properties and so on and so forth. What I guess probably everyone is familiar with is something like a customer. So a customer class, let's say. So your average organization probably has a CRM, and the CRM does have the notion of customer and certain properties that the customer has. Data, a customer data model in a CRM probably has an email address, or I don't know, a number of campaigns that they've reached out, and so on and so forth. But then they also have like system for, I don't know, invoicing or finances, and they definitely have a customer there. So they may have properties such as their bank accounts or previous payments and so on and so forth. And you get the picture. Probably every single system that an average organization has must have some notion of a customer. So and the reason I'm mentioning that is that I think it's a good example to kind of figure out, so how do you integrate all of those, and how do you keep track of different properties, potentially conflicting? Because, well, let's take email. You may have a property for a customer's email in your CRM, and you may also have another property for the same customer's email in your invoicing system. And they may be called different names. And obviously, you're going to have different operations that you can do in your CRM and in your invoicing system. So, how do you reconcile those? And well, how do you, after you do, does that mean that you only have to, as an application builder, do you only have to interact with the enterprise web notion of a customer? And if you do, are you then able to execute every potential method, let's say, every potential function, every customer object across your different systems has?
Yeah, so that's actually a great example, and thanks for bringing me back down to earth to maybe a more human accessible use case here. So people tables, of course, are the great customer tables. I like those are like the common canonical references for like master data management or any kind of things like that. So part of it, I would say, is, well, there's some things that we're going to just have to do. They're just functions of that effort, right? And then, but it does make a difference about how we're doing it, right? Traditionally, master data management hasn't worked out too well, right? Despite good intentions and spending lots and lots and lots of money on systems and system integrators and all those things like that, because it tends to drive towards a centralized and static representation of those concepts, right? I think that's fair. And even to date, right, is like the problem is as soon as things become static, you're dead, right? Because the truth that you're unveiling is nobody has one representation of customer. They have many representations of customers across, and same thing with people and many, many, many other concepts across the system. And it's completely normal for us to start because we're an enterprise grade solution. The first thing we always do is normalize all the core ERP tables, right? You just have to do it because, well, we go to our customers like, we don't want to just be another people table or yet another customer representation, right? We're an integration system. We're about interoperability and automation across these things. So it's one of the things we do. We call it a phase 0 of any project, is to take the core ERP concepts because they're core for everyone, right? Everyone has a notion of customer, right? Pretty much, right? And people and things like that. So our baseline model, of course, has those representations as well. At the graph knowledge base, at the upper ontology level, they are abstracted away from detail, right? To be pure concepts, which means that they can be universal, right? And that they can be, that we can map things up to that concept, and it supports a form of normalization, right? And so in EnterpriseWeb, the way we do it, to your very specifically though, is we would onboard each of the participating systems or databases or services, right? We don't onboard them all discretely in the process I defined just before, right? Each one of them would be, okay, let's model this source. It's a database. What's it exposing? Right? What's this one? It's it's a service and endpoint, and it's a cloud service. Somebody's using CRM in the cloud. They have a separate notion of customer over here. Fine. Well, let's onboard them all. They're obviously different types of endpoints, right? One's a on-premise database, one's a cloud-hosted service, but that's okay. They're still providing data. In this place, they're not functions or applications pretty much. They're providing data to us maybe in the first instance, but they could be things that consume enterprise web ultimately as well. So we'd model all of those discrete endpoints, and then you essentially create an entity representing the union of all of them for a concept, right? And that would be a mapping, right? So essentially, it's the minimum viable mapping of the common properties across them, right? And for us, actually, generally, when we're talking about data now, but again, remember, you do this for everything. So if we go back to the router example, it would be the properties, the behaviors, the dependencies, the constraints, the minimum viable mapping. At what level can we say a customer is a customer is a customer, a customer across all? Use a common set of metadata. And what do customers relate to? Can we create a common set of relationships where customers relate to things so we can understand semantically what a customer is, right? Can we create that minimum viable metadata and domain semantics such that we could use it to query and discover any of those sources, create an aggregated resource, mapping and merging where possible. But also, this is, I think, an interesting aspect of enterprise web, is to the extent that there are idiosyncratic or unique properties for a certain source, because that's another thing that happens, right? So obviously, we could say that these customer tables would have overlapping things, right? Maybe different labels, but they'd overlap. Maybe we have some things with contention. That's also true. But you also might have unique properties that you collect only for certain things. And certain systems collect certain things, and certain systems don't collect certain things. That's also a true case, right? So you normalize to the extent possible. That's normalizing up, your mapping, right? And then within the objects, we're still going to capture any unique properties because we want that object to be very rich and complete, right? At least complete enough to support your use cases, right? So again, minimum viable for each individual one, and then a normalization of the whole. But they're in enterprise web. Consider for a second. Each one of those objects is an immutable object. They all have version control and audit history, right? So we can actually version every discrete source that's contributing to that aggregate. The aggregate itself is yet another object in enterprise web. It too is an immutable object that can be versioned, right? And it's part of the greater model. That greater model is also an object in enterprise web, made out of concepts in enterprise web, which are also all objects. And that homoiconicity, that kind of consistency in design, top to bottom, where everything's just an object, right? Everything is an abstract data type. Everything is made up of references, and all those references get computed in real time to interpret what these objects are. That's actually a very powerful capability in enterprise web. So again, you and I, you're technical and you're academic in nature, and so we're going into details. I do want to remind you that every once in a while that we're a no-code platform. What we're talking about, we just made look easy. You know, we jumpstart the modeling of your domain. We make it easy for you with a wizard to onboard your objects. We also, even on the objects level, if you have a file or anything else like that, that we could use a JavaScript, HTML, JSON, XML, anything that we could take in, import. Again, at the object level, we can import those schemas, things like that, to bootstrap those modeling efforts as well. So we streamline everything where we can. We make them all available in a catalog. We make that catalog composable. Every object in the catalog is version control and with audit history. So I could be working with an implementation that is composing a certain set of objects together under a service definition, let's say with the term customer, that might have relationship to 5 systems. One of those systems might get updated, right? And so, but the rest of the systems are all saying the same. I want to now represent, essentially update my object in my catalog, essentially, which is it's append only, so capture the differences, what's changed for that single source of customer. I want, if necessary, I might have to remap that to the higher level concept of entity of a customer to keep everything normalized. But everything was version controlled. If something breaks, we know exactly where it broke, right? Because it's a graph. It's inherently traceable, right? It's fantastic for debug. Everything's version controlled, so we have the history of the way things were. We know which version is being used today, and so you have sort of this graph introspection of everything in all directions, which is also very powerful, right? So history itself is sort of part of a graph walk of a single object, right? It's the timeline of a particular object is actually a set of relationships over the changes. So, I'm going into we're diving off the deep end here, and I'm always wary of doing that, George. My intention is to communicate, and I hope for a certain audience this is making good sense. Am I being clear? Does the parts that are common to master data management is an idea about normalization, and same thing with the data fabric, data mesh is an idea about aggregating at least all of your endpoints into a catalog, and we're bringing those both together in one idea, which is to say, actually, I'd like to have a catalog with normalized metadata and relationships. I'd like my mesh or my fabric to be navigable across, and actually not just navigable. I want to use that same metadata and domain relationships as well as the actual state, because we have history. So we have the history of transformations on any object. So state, I want to use metadata, relationships, and state to drive automation, right? Intelligent orchestration, event-driven processes. That's a big deal. We have this in production now for many years. It doesn't break, and it's scalable. So we've taken these ideas. The implementation itself is cloud native. So EnterpriseWeb, this whole notion that we're using Graph 2 and everything's in a catalog, and catalogs are just references, means that we're not even really, you can't really call us a monolith either. We're virtually centralized, but everything is really captured in a very decomposed way, right? In a very loosely coupled way in EnterpriseWeb. What we're doing is providing sort of the unified management layer over the top, common transparency, so that you could manage your enterprise, right? We're enabling an enterprise to have one logical representation of its solution elements so they can act as a unified enterprise. And that's the whole thesis for EnterpriseWeb.
Well, actually, we're almost out of time, so I think we can address maybe one last topic before we have to wrap up. And I was actually going to tie this up to this whole customer class, let's say, discussion, and ask you if you have any kind of real world, let's say, use case that you could share around that. So any kind of business process that you modeled around customers, such as, well, orders or fulfillment or this kind of thing that you think is a good example.
So excellent. So we actually just did a great use case in collaboration with some contacts at SAP. And obviously, if you're in the integration and automation space, given the widespread of adoption of SAP, it's impossible not to have integrated an SAP the customer somewhere in your life, right? But in this case, SAP reached out to us because they wanted to understand essentially the state of graph knowledge bases, and if a graph knowledge base could sufficiently describe a systems domain such that you could then use the metadata and relationships like we're describing to drive automation. So they really were looking for something exactly what we do, right? It's sort of really funny. They came to us after your event last year, your knowledge connections in 2020. And so that was great. They heard about us, I guess, a couple of times. They read one of my articles and heard about us from some of their other contacts. But then they saw our presentation last year and they reached out to us. They had just hosted a hackathon. SAP Labs had hosted a hackathon for its Unified Ontology Challenge. And we didn't do that exactly. We got our own sort of special project from them. which was order to fulfillment, right? I mean, again, sort of just like customer, order to fulfillment is sort of the classical
Hmm.
exemplar of a process. And I mean, like everybody else, SAP really just wants to see if they can make it easier for customers to connect and use their, with their product portfolio, right? Their services, and that's what we set out to demonstrate for them. So the hackathon gave us, we used the assets that were already exposed in the hackathon. They had models, files, and access to endpoints. Again, we had a little bit of a special enterprise web specific mission that SAP had given us. And then we did a big presentation to SAP stakeholders worldwide for them. But the use case, again, will be one that I would think a lot of your listeners would appreciate. SAP order to fulfillment. And we started actually almost in the exact flow that we discussed earlier. So that development workflow or design workflow that I discussed was start with the domain. Well, what was the domain? The domain was SAP. That's a pretty big domain. How did we now, of course, in our generic enterprise concepts, we already have notions of people, places, things, right? A lot of those kind of things, orders, locations. So a lot of those things would already exist in Enterprise Web. But what we were able to do is SAP has a really nice piece of work. It's called their one domain model. It's actually a graph. So they call it their graph API. Now, it's a graph in the sense you can navigate it and you're navigating products. It's really almost a graph of their products. And then when you find products and you have to discretely dig into each one, there's no higher level above them, right? There's no connecting meta model over the top of it, right? It's just, essentially a graph of their products, and then you could drill in and see their objects and their schemas and things like that. So they gave us that as a file. We were able to access the SAP Graph API, import that model, do the entity extraction, the algorithmic mapping, blah, 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 in seconds. We actually do this live on, there's a YouTube demo out there. I'll share the link with you and you can post this hopefully. And we do this live, we import this model. It then essentially we're wrapping the one domain model in the enterprise web's graph knowledge base. We're wrapping it with our type system and our domain, our sort of enterprise concepts. Does that make sense, right? So it's now part of a bigger connected model, right? In the sense that we're taking their objects, we're extracting the schemas in their interfaces, we're mapping all those details. The system's doing that instantly, right? It's extracting the types and the formats, all protocols, all those things like that. It's all just done. Again, maybe some manual massaging, right? Because I'm not going to misrepresent that. But it is essentially 95+% automated. Then once that is done, you're left with really just a couple of steps. Like I said before, now an IT person might come in and onboard some of the solution elements, some of the runtime engines, in this case, some runtime engines that are necessary for the SAP runtime engines that were necessary for the end-to-end processing of the order to fulfillment. So they onboarded those, like I said, in 30, 60 minutes, whatever. We onboarded a couple of their components. So it's part of a federated solution. So that's actually interesting too. Enterprise Web doesn't have to do everything. Yes, we can do integration dynamically ourselves. Yes, we do orchestration ourselves. Yes, we do automation, configuration, connection, networking configuration. Do all those things, can do those directly. But because we're an integration platform, we're inherently open. We're working in a federated mode. So we imported their components so they could be part of this hybrid SAP Enterprise Web solution. Then, let's say a service designer came in and wanted to build a process over the top of these various endpoints, right? These various SAP and non-SAP endpoints. And they modeled the process in Enterprise Web. They bootstrap that again by importing an existing artifact. Well, I should note that SAP's one domain model is an OData, so that's just yet another format that we can import. right? OData is known to everybody in the SAP community. For the process, they had a BPMN file because that's what they use at SAP, right? So they give us BPMN file. Of course, BPMN is not cloud native. BPMN is not event driven, right? BPMN is a lot of things, right? It's a traditional application process modeling technology. We took their BPMN. It's fine. We extracted the tasks, the roles, the integration points. Once again, we're taking a file, to bootstrap the modeling of the process. But in this case, now we're doing business transformation, right? We now extracted their BPMN details, brought it now into EnterpriseWeb, where it's going to be reconstructed as a cloud-native event-driven process. That's done almost instantly. If you do watch the YouTube demo, the demo component is about 15, 20 minutes. In 15, 20 minutes, we do all those 3 steps. We import the one domain model. We set up the runtime. We onboard the components. So a solution architect sets the domain. IT people set up essentially the environment, and then the components necessary for the environment. And a process designer or service designer comes in, models the service or process. And all of that was done in 15, 20 minutes, logging in and out as different roles, all starting with different artifacts. So you could do everything manually in EnterpriseWeb from scratch. Obviously, that would take longer because you're doing the initial work from scratch. But again, you have to think about the mission of EnterpriseWeb. The mission of EnterpriseWeb is to be a no-code platform for IT productivity, rapid service delivery, and business agility. And so we're trying to make it as easy as possible to do what would be hard, what would be tedious and time-consuming. And now in EnterpriseWeb, that process is, we essentially, a customer can create an order that's going to be an event in our system. It's going to trigger the order to fulfillment process. It's going to run across those endpoints. It's now a truly cloud-native process, all running in EnterpriseWeb. Well, I'm sorry, running EnterpriseWeb is the higher level model, providing the higher level metadata, consistency layer, the domain semantics, all those kind of things like that. The higher level coordination across all of their endpoints, SAP endpoints and non-SAP endpoints, to deliver an end-to-end solution. This is a problem every single enterprise in the world faces, various shapes and forms. It's the same problem everywhere. And so we do this in life sciences, we do it in telecom, we've done it with SAP, we've done it in other places. I think the idea here is you'd like to have a high-level abstraction and common tooling. The absence of high-level abstraction and common tooling is why everything feels like it's spinning out of control right now in the development world, in the application development world. And so by creating a unified abstraction, common tooling, we're essentially recreating those common principles or unifying principles that existed in the mainframe for now a new distributed environment. And I would argue that without those unifying abstractions and without common tooling, you'll never get there. It's, again, you just have to go to the N+1 problem. If you try to hard code this with middleware stacks and cloud native tools, your middleware stacks will become bloated, your tool chains will become unwieldy, you won't have a common abstraction across them. When something breaks, you won't know where it broke, and now you are a slave to your tools. Your accidental complexity now throttles your domain problem, right? EnterpriseWeb hides the systems complexity so that we can enable the inherent domain complexity of a complex distributed system.
Well,
how'd I do?
I think we've come full circle. When we started, you mentioned mainframes, and then now we've kind of talked about mainframes again. So it's like a full circle. I just have one really quick question. Were the SAP people happy from what they saw?
I can't make representations,
Okay,
and so you'll have to excuse. I could say that our contacts were thrilled. And the kind of responses we get are like, how do you do that? I can't believe you could do that. That looks like magic, right? And it's not magic. I think we've now methodically sort of walked through on this call. And of course, there's even more technical details that we didn't cover, right? There's how our graphs are assembled, how our graphs are processed. Clearly, we could do another 2-3 hours of conversation. It would actually be a great joy to do it with you. However, we did methodically sort of walk through the logical architecture together, right? How we use graphs to make these things easier.
Great, thanks.
Great. Thank you, George.
I hope you enjoyed the podcast. If you like my work, you can follow Linked Data Orchestration on Twitter, LinkedIn, and Facebook.